So in this problem, you see we are given the member of the truss which are connecting at joint A. And you see we are given the force 2 which is acting at the member 2 which is about 6 kilonewton. And we have to find the force F1 in the member 1. And you see we have to also find the angle which this member makes with the x-axis. So in this problem, we use equilibrium conditions to solve this problem. You see, if I take all the forces in x direction, I assume that the forces acting in the x direction is equal to 0. So I get this 6 kilonewton force that is basically the force to, and you see, this member makes an angle of 70 degrees with y-axis. So you see that, so we use the vertical component sine in this case, and see this is the force F1. I see this member makes an angle of theta with x-axis, so I use its horizontal component which is cos theta. And you see in this member we are given 5 kilonewton force, but you see this force is acting in opposite direction of x. So this is negative and it makes an angle of 30 degrees with x axis. So we use the horizontal component force. And you see in this member we are not given the angle, but we are given a right triangle. So cos is basically equal to base over hypotenuse. So this is 4 over 5 and the force is about 7. So when I solve this, I get the equation which says the force in the member 1 with its horizontal component force of theta is equal to 4.29 kilonewton. And you see, if I assume that R the force in y direction equal to 0, so I get this 6 kilonewton force with the horizontal component force angle 70 degrees plus 5. I see this is vertical component sine angle 30 minus F1 sine 30 minus, you see, basically sine is equal to perpendicular over hypotenuse. So this is, you see, this is perpendicular 3 and hypotenuse 5. So this is 3 over 5 and force is 7. So it's equal to 0. So I get the other equation which says I have the force in the member 1 with vertical component sine theta, which is equal to 0.3521 kilonewton. So you see tan theta is basically equal to sine theta over cos theta. So if I divide these two terms, I get f sine theta over f cos theta is equal to 0.3521 over 4.2920. So you see tan theta is equal to this term. So if I take this, so it becomes tan inverse and I get the angle which is 4.69 theta. You see this angle is about 4.7 theta. And you see, if I put this angle in equation 2 or in equation 1, I get the force which is acting in the member 1, which is about 4.31 kilonewton.